Yeah, students, today I thought I will explain to you some of the numerical problems based on units and measurements. So, the first example, let us take a look at the first example. The mass of an electron is 9.11 into 10 to the power of minus 28 grams. How many electrons would make 1 kilogram? The question is quite simple. So it says one electron has 9.11 into 10 to the power of 28 grams. This is the weight of one electron. How many electrons should be there which will weigh 1 kilogram? So it's pretty simple here. If you put x electron here, so you can just cross multiply unitary method and you will get that answer here. So x number of electron multiplied by 9.11 into 10 to the power of minus 28 is equal to 1 kg. So this will come down here. So you can make it as x number of electron is going to be equal to 100,000 grams we will put, because this is also in grams, we will put it in grams here, divided by 9.11 into 10 to the power of minus 28. So finally you will get an answer as 1.1 into 10 to the power of 30 you will get. Okay, so this is also grams, this is also grams, the grams will get cancelled out, so we'll get this is the number here. Next question. The average distance of Sun from Earth, it is 1.496 into 10 to the power of 11 meters. This is an astronomical unit. We already have seen this one. It's called 1 AU. Expressed in light years and in parsec. We know the largest unit there are three largest unit. One is astronomical unit. Next one is light year. Next one is parsec. So we are supposed to find out how much this one in terms of light years. So we'll write the expression here. 1 astronomical unit is equal to 1.496 into 10 to the power of 11 meters. Already we know this one. We already know also 1 light year is equal to 9.46 into 10 to the power of 15 meters. So if you want to find out this distance in terms of light years, so what you need to do is divide both this one. Divide both of this relation. Once you divide both of the relation, just put divided by. So you get this particular thing. 1 AU upon 1 light years is equal to this much. Now meters and meters will get cancelled out. So what you will know? 1 AU is equal to this light year will get cross multiplied, and finally this whole thing, whatever the answer you get, that's going to be the answer here. It will be 1.58 into 10 to the power of minus 5. This has gone up there, light year. That will be 1 AU. So that's a easy calculation that you will get here. Similarly, the second part of the question says, find the same expression of one astronomical unit in terms of parsec. So you write the expression once again. 1 astronomical unit is equal to this much, and 1 parsec is equal to 3.084 into 10 to the power of 16 meters. We already know this one. Divide both this one. So once you divide both this one, you will get here as 1 astronomical unit and 1 parsec division thing is there. So these 2 meters it get cancelled out. Now this whole calculation, find out and write the answer. So that calculation makes it to be 4.585. So 4.85 into 10 to the power of minus 6. So 4.85 into 10 to the power of minus 6. This parsec will go up. That is an answer here. Moving to the next question. A new unit of length is chosen such that the speed of light in vacuum is unity. So they are considering a new unit of length. There is a new unit of length they are deriving, keeping that entire distance. What is the distance? The speed of light in vacuum. That is, they are going to consider it as a unit here. What is the distance between Sun and the Earth in terms of the new unit if light takes 8.8 minutes and 20 seconds to cover the distance? So this is a question usually the light takes from sun towards the earth, it takes 8 minutes and 20 seconds to reach the earth. So in terms of the new unit, we need to find out how much it's going to be the new unit value. So the speed of light in vacuum, it's taken as unity here. So 1 unit is equal to the speed of light, you know the value here, 3 into 10 to the power of 8 meter per second. So this is the speed. Now what we know is they are asking of the new unit of length. Length means it should be just in meters. So it is in 1 second, this much distance it travels means, so the new unit is going to be equal to having this much as the length. So that basic things we need to understand and we need to keep it in mind. Then they are already given here the distance between earth and sun. The time taken by any object or the light to come back to this place is going to be equal to 8 minutes 20 seconds, which is going to be equal to 500 seconds. So it takes 500 seconds to reach earth, the sun light to reach earth. So light takes 3 into 10 to the power of 8 meters it travels in 1 second. So the total distance which is going to be equal to this much speed into that 500 seconds, because the distance between the earth and the sun, if you calculate this much whole thing it's going to take, so that is going to be the total distance from sun till the earth. So this gives the basic calculation here. So we know here 1 unit, we already saw this one, 1 unit is going to be equal to 3 into 10 to the power of 8 meters. So 1 unit is going to be this much. So how much units is going to be equal to this whole value put here, 3 into 10 to the power of 8 into 500 meters. So when you do the unitary method, then you get the value of x here. So x is going to be equal to 3 into 10 to the power of 8 into 500 divided by 3 into 10 to the power of 8. So these two values get cancelled here. So x is going to be equal to just 500 terms of the new unit here. So that's an answer. So the next is equation number 5. It talks about the conversion of units from one unit to another. So you have 1 centimeter, how much it will be in meter cube. So if it is the 1 centimeter is the one side of a cube, how much is going to be equal to the volume. So you need to find out the volume formula as well as put the conversion and then do it. Similarly, the next question is surface area of a solid cylinder is given here, radius is given here, height is given here, in both of them in centimeters. How much it will be the volume if you write in millimeters. You need to convert this one into millimeters, convert this also into millimeters and calculate this one. Same to the next question also. It is given here as a vehicle moving with a speed of 18 km per hour. Convert this one into meter in 1 second. So meter per second you need to calculate. You already know this one. So you can calculate this. Relative density is given here as 11.3 and its density in gram per centimeter cube or kg per meter cube is already asked. So that also you know these calculations. You can do it yourself. So we'll move to the next question here. Question number 6. So question number 6, it talks about fill in the blanks by suitable conversion units. So 1 kg meter square per second is given here. How much it's going to be in grams centimeter square second minus 2. So this one is a calculation which you need to do. The calculation we can easily try. So that's going to be equal to 1 kg in terms of grams. How much it will be? 1000 grams. Meter in terms of centimeter. How much it will be? 100 centimeters. Is going to be 1 meter. So it's already square is also there. Second and second it is same. So in terms of gram centimeter square and second minus 1, this is going to be the conversion here. So 1000 into, so this is going to be 10 to the power of 4 because 10 square in this one, and it's going to be, this is 10 to the power of 3 and into 10 to the power of 4, that's going to be equal to 10 to the power of 7 gram centimeter square second minus 1. That's the one which is given here. The next one is 1 meter in terms of 1 meter in terms of light years. We already know this one. 1 meter in terms of light year is asked. 1 light year is equal to this much meters. So what is 1 meter? This entire quantity will come down. So 1 meter is equal to 1 light year divided by 9.46 into 10 to the power of 15. So that's going to be the value here. When you do the conversion, you will be able to get the answer. So the answer is, this is the answer you will get. It is 1.06 into 10 to the power of minus 16 light years. The next part is 3 meter per second square in terms of kilometer per hour square. So when you convert this one, 3 meter per second square, this is equal to 3 you need to put, because 3 also it comes here. Meter in terms of kilogram, that's going to be equal to 1 upon 1000. We know this one, 1 meter is equal to 1 upon 1000 kilometers. 1 second in terms of hour square, it is 1 upon 3600 seconds. Now this is already here minus 2. This is also minus 2. So to the power of minus 2 it will be written here. So when you do the calculation, 3 into, this one goes up, 3600 into 3600 divided by 1000. This gets cancelled here, and the rest of them you can write it as an answer. The answer which is given here is 3.888 into 10 to the power of 4 kg r minus 2. So that's going to be the answer, 3.888 into 10 to the power of 4 kg, this kilometer r minus 2. So that's going to be the answer here. Right? The next question is 6.67 into 10 to the power of minus 11. This is the value of G, gravitational constant here. Newton meter square kg minus 2. This one has to be converted into centimeter cube second minus 2 per gram. So they are asking us to convert this one into a CG's unit, of course, but Newton is not there as a dyne here. Meter square is given here, of course, centimeter cube it has come here. Kg minus 2 is here. Now gram minus 1 is there. Look at the minus 2 has become minus 1. So what are the changes that has come here? Newton, they have applied the term in terms of kg meter second minus 2. So instead of Newton, you put this value right inside. So what happens here? So kg meter second minus 2 in terms of Newton you have put here. Now this is had to be put here, meter square. This has to come here, kg minus 2. So you get here as meter square and meter will get here as meter cube. Kg and kg minus 2. You will get this one as kg minus 1. And here second minus 2 is there, that is second minus 2 is the same. So this is the way in which it has come now. So this is the final SI unit of the same thing. The same SI unit can be written as this way. Now this part, it has been converted like this. So when you convert this one, what are the various variations that you need to give? Second is the same, meter cube, when it becomes centimeter cube, so you get here as 100 the whole cube. And then kg minus 1, it is going to be gram minus 1, so it's going to be 1000 into minus 1. And then the 6.67 into 10 to the power of minus 11 also it comes here. So it is going to be 6.67 into 10 to the power of minus 11, and this entire quantity is there. So this is going to be 10 to the power of minus 6, and this is going to be 10 to the power of minus 3. Final answer will be 6.67 into 10 to the power of minus 8. You will get 10 to the power of minus 8 as a value here. And what is the SI unit? Centimeter cube second minus 2 gram minus 1. This will be the value here. The next few questions of the NCERT, there are some of the NCERT problems are given here. Example number 7. You can just go through it. These questions may not be so important here. So you can just go through it, how it is this much of distance approximately it is calculated. And similarly here also you will find this one, question number 8 and question number 9. And these are the questions. Question number 10 also. These questions you can just go through it. It may not be so important to see. There is a lot of approximate methods that has been used in this method to find out what is the distance or what is the kind of a size and all these things, area, it has been calculated here. Yes, similarly this kind of a empirical relation also it is given here, and that is a numerical related to this particular thing. You can just go through this one. It is just a ratio of 2 volumes it's given here, and this is just a basic question. I would like to draw the attention towards question number 12. A laser beam aimed at moon takes 2.56 seconds to return after reflection at moon surface. Find the radius of the lunar orbit around Earth. So it talks about this particular format here. From Earth, you are putting a laser beam. It goes straight to the moon and then gets reflected and comes back. So they are asking what is the lunar orbit, because the moon also rotates around the Earth. So what is the distance between Earth and the moon, they are asking here. So they have given few things. The total time taken, it is given here as 2.56. It's given here as 2.56 seconds it takes. So time taken is 2.56 seconds. Now this one, when it goes, the laser goes and comes back, it takes the speed of light. The speed of light, it is given here as 3 into 10 to the power of 8 meter per second. So that's called as c. We can call it as c is the speed of light. Now the distance is, it goes one time and comes back. So it is x we take here and again x we take here. So it's going to be 2x is going to be the distance. 2x is going to be the distance here. Now what we need to calculate is, we need to calculate the value of 2x. So distance is equal to the velocity c into t. So 3 into 10 to the power of 8 into 2.56. That's going to be x here. 2 can be brought down. You can bring 2 down, and that will be the distance you can calculate. So the calculated distance you get here as, after calculation, it is 3.84 into 10 to the power of 8 meters. So that's the value which you find here. Okay, the same value is given here also in the book. 3.84 into 10 to the power of 8 meters. Similarly, that another question is also given here. In a submarine equipped with sonar, the time delay between the generation of the ultra probe wave and the reception of its echo after reflection from an enemy submarine is found to be 77 seconds. What is the distance of the submarine? Speed of sound in water is given here as 1450 meter per second. So this can be imagined like this. There is waters, so it is all full of waters here. So this is the sonar machine. A source of the light is there, and it has been giving the sonar. It goes and gets reflected back from the submarine. Let us imagine this is a submarine, and it comes back. So it travels a distance of x here, again comes back to the distance of x here. This velocity is given here. Velocity is equal to 1450 meter per second. That is the speed of sound in water. You can easily calculate. If you know, this is going to be the total distance is going to be equal to 2x. This is the velocity, and we know the time taken. It is given here as 77 seconds. So the same formula, x is going to be equal to velocity into time divided by 2. So it becomes 1450 into 77 divided by 2. So the answer you will get here and the distance which you will get here, which is 55.8 kilometers. That's the distance. So the next question I would draw your attention to is to example number 18. The nearest star, Alpha Centauri, to our solar system is 4.29 light years away. It's a quite a far away distance. How much is this distance in terms of parsec? It is given in light years. We need to give the answer in parsec. How much parallax would this star show when it is viewed from two locations on the Earth, 6 months apart in the orbit around the Sun? So there are two questions given here. One is we need to find out this value in terms of parsec, and then we need to also find out the parallactic angle also we need to find out here. So if we see this one, Earth is here, nearby star is here, we can consider this distance is going to be S. One light year we already know it's going to be 9.46 into 10 to the power 15 meters. And we already know this one also, that this distance, the distance when they measured in light years, this S, the same distance was given in light years as 4.29 into 29 light years is given here. So what is the distance here in terms of meters? So it's going to be 4.29 into 9.46 into 10 to the power 15. That much meters it will be. So you can calculate the distance in terms of meters here. But this is just a distance in terms of meters here. Now what they have asked, how much is the distance in terms of parsec they have asked. So 1 parsec you can write here as 3.084 into 10 to the power of 16 meters. We already know this value. So this distance is given in terms of meters. 1 parsec is equal to this much. Divide both this one. So divide this value. Divide this one and divide this one. Put equal to in between. So meters will get cancelled out. So this one, it can be taken in terms of parsec, we can calculate here. So the distance in terms of parsec, when after you calculate everything, it will be equal to 1.32 parsec you will get. So it will be 1.32 parsec you will get here. So that's the first part of the question. This parsec goes there and then you will calculate this one and you will get this 1.32. The second part of the question is, the B part you can say, so what is going to be the parallactic second it is asked. So it means the Earth is here and the nearby star is here. This is the distance they have calculated here and the same distance is also here. So from here they are seeing this particular star. After 6 months down the line, Earth goes to the next side and again they are reviewing the same star. But what they were able to find out is there is an angle it makes here. The angle we need to calculate. So when Earth from this side and it has come to this side, it has traveled for this much distance. If you take the complete diameter of the orbit, 1 astronomical unit, it is the radius of this one, and another astronomical unit. So the total value is going to be 2 astronomical unit. And the distance already we know here. The distance is already given here. Knowing this one, knowing this particular thing, we can calculate phi. It is length of the arc. So phi is going to be equal to length of the arc upon radius. We know this formula. What is the length of the arc? This is the length of the arc. Or approximately is going to be equal to diameter. So it is going to be 2 AU upon this distance. Now what is this distance? This distance we already calculated as 1.32 parsec. Right here we calculated this one. We just calculated this one. This distance is going to be equal to 1.32 parsec. Now we need to find out the angle here. 2 astronomical unit upon 1.32 parsec. If you calculate in terms of meter also you can get, but we have to little use your wisdom to find out what is parsec. Parsec is basically, it is the distance, horizontal distance, when an angle of 1 second subtends with the perpendicular distance of 1 astronomical unit. When this distance is going to be 1 astronomical unit, this right distance in an angle of 1 second, it will be equal to 1 parsec. So we know this particular thing as 1 second is equal to 1 AU upon 1 parsec. In other words, 1 parsec is equal to, if you cross multiply this one over here, 1 parsec is equal to 1 AU upon 1 second. So this particular relationship, you can straight away put it here. Take out parsec, take this parsec outside and put this relation there. So we can write it as phi is equal to 2 AU upon 1.32 into parsec is removed. We need to put this one 1 AU upon 1 second. AU and AU gets cancelled out. Now 1 second is underneath, it goes to the top, and this goes for the calculation here. So phi is equal to 2 upon 1.32 seconds. This is the angle which is here. This is going to be the angle here. So if you do this calculation, 1.515 will be the value here if you do this calculation. That much of seconds of arc. You will get this as an answer here as phi. So this is another question which you might have difficulties, and it's also an important question. So it goes from distance of the star in parsec, and then we apply the parallax method formula, and then we find out the value of phi, and the final value is going to be equal to 1.515 seconds of an arc.